Hello everyone, welcome to Engineering Archives. Let's now look at our practice problem number 4. So in this question, they say determine the design angle phi. This symbol stands for phi, or you can just call it theta. So determine the design angle phi between struts AB and AC so that the 400-pound horizontal force has a component of 600 pound, which acts up to the left in the same direction as from B towards A. Take theta equals to 30 degrees. So this is theta and this is phi. Theta is given to be 30 degrees. So let's first start by drawing the axes and how they would look like. This is our AB axis, and this is our AC axis. This angle in the middle is phi, while this angle is given to be theta, and is 30 degrees. They have also given us a horizontal force that acts to the left, and its magnitude is 400 pounds. And in addition to this force, they have given us a component of this force that acts along the AB axis. In other words, this component right here. They have given us this component, and the magnitude of this component is 600 pounds. And what they want us to find is the angle phi. So let's start drawing the vector triangle. The first vector that we can draw is the easiest vector, in other words, the horizontal 400-pound force vector. Next, we can draw the 600-pound component vector along the AB axis, like this. And finally, we can draw the component along the AC axis, which should look like this. So this is FAB, well, this is FAC, and this is just F resultant. Now let's put in the angles. So the angle between the resultant force of 400 pounds and its component along the AB axis, this angle should be equal to this angle right here, which is 30 degrees. As you can see that these two angles are opposite to each other. In other words, they should be equal in magnitude. So this angle should be 30 degrees too. So let's put that right here, 30 degrees. This angle should be equal to this angle right here, as this is the angle between the AC axis and the AB axis. In other words, the angle between the two axes. And right here in the diagram, we can see that this is the angle phi between the two struts AC and AB. So this angle should be phi. Lastly, this angle should be just 180 minus phi minus 30 degrees. In other words, 150 minus phi degrees. Now that we have our three angles, and also we have the length of two of the sides, we can solve for the angle theta. Now you might be wondering that, wait, we don't have the value for the angle phi, or the angle 150 minus phi, and we don't have the value for this side AC. But the thing is that we have the length for two sides, and we have the angle between those two sides, that is 30 degrees. So if we apply the Cauchy rule, we can easily find the length of this final side. And once we have the length of all three sides, we can simply find the angles using the sine rule. But instead of doing this lengthy procedure, we can use a shorter procedure by using the sine rule, and I'm going to show that to you right now. But all that I'm asking you to realize is that even though we don't have all the values and all the angles, we do have enough information that we can move on and we can find the value of phi. And we can understand that by understanding that if we go through the lengthy procedure that I just mentioned, we can easily find everything. So let's use this shorter procedure, that is by using the sine rule immediately. So the sine rule. If you don't know what the sine rule is, you should just Google it up. So according to the sine rule, 400 pounds for sine of the angle phi should be equal to 600 over sine of the angle 150 minus phi. Right, so now we have set up our formula, and we can see that in this formula we have only two unknowns, only one unknown, I mean, that is phi. Alright, so let's just evaluate this equation. So 400 sine of 150 minus phi is equal to 600 sine of phi. Now we have a compound sine right here, which means that it's the difference between two angles. So we can expand this by using the formula that you need to memorize, and that formula is sine of A minus B. I'll write it right here. Sine of A minus B is equal to sine of A cos of B minus cos of A sine of B. So using this formula, we're just going to expand our sine of 150 minus phi, and what we get is 400 times sine of 150 cos of phi minus sine of phi cos of 150 equals to 600 sine of phi. Alright, so divide 400 on both sides, and what we get is sine of 150 cos of phi minus sine of phi cos of 150 should be equal to 600 divided by 400 is 1.5. So 1.5 sine of phi. Now simply just add cos of 150 sine of phi to both sides, and what we get is sine of 150 cos of phi should be equal to 1.5 sine of phi plus cos of 150 sine of phi. Okay, now this should be equal to sine of 150 cos of phi should be equal to, take sine of phi common, sine of phi 1.5 plus cos of 150. Alright, now divide 1.5 plus cos of 150 on both sides. On both sides. Plus cos of 150. Cancel these two. And so what we end up with is, we'll just use the page below. So what we end up with is sine of phi should be equal to sine of 150 cos of phi divided by 1.5 plus cos of 150. Now divide cos of phi on both sides, and we end up with sine of phi over cos of phi equals to sine of 150 divided by 1.5 plus cos of phi. So as you can see right here, on the right side of the equation, all we have are numbers, and we can simply solve this on a calculator. On the left side, we have sine of phi divided by cos of phi, and this is equal to tan of phi. So tan of phi is equal to one big number that we're just going to solve on our calculator. Let's just call that number this. Okay, actually let's just call it a star. Okay, now once we do the arctan of both sides, we get phi equals to tan inverse, I'm just gonna write the whole thing here, sine of 150 over 1.5 plus cos of 150. And once you solve this on a calculator, the answer that you should get is 38.3 degrees. So this was the procedure, the shorter procedure to get the value of the angle phi. Had we done the longer procedure and used the cos rule, then we would have to first find the length of this side, and then we would have to apply the sine rule to get the angle phi. By using this procedure, by directly using the sine rule and this formula to expand the compound sign, we were able to get the value of phi easily and more quickly. So just practice with this a bit. Thank you very much. See you in the next video.